Hello guys, welcome back to another video from my channel. In this video, we are going to discover some features in the Envi software, uh, such as bond mat, spectral indices, and something. And the bond mat is one of the most important tools in the environment of the Envi. So here, when you click here, you can use any type of formula here to and logics to process, rescale, calculate the indices, any any arithmetic of the image, any calculation, and it depends. The capability of this tool depends definitely on your ability on defining the um, formulas and the calculations. So what we are going to discuss today is scenario. We're going to evaluate some uh, index formulas. Then we're going to classify our created index image according to decision tree, according to its classes and the platform. The decision tree, we're using decision tree tool. Then will export the data through the uh, export tool uh, as a shape file, or we can save it as a shape file. So let's try it. I'm going to open my image. This is a Landsat 8 image that we have here, and I'm going to subset part of this image and use as my study area. Because of this, I have to apply a ROI here, and I'm going to rename this what to name this. Imam Sahib. The name of this area in north of Kunduz province in Afghanistan. So now I'm going to apply a radiometric calibration to this image here, multispectral, and all the seven bonds of this image will remain in this processing, but especially I'm going to cut out this image from here just okay. Okay, then here it's going to be radians, BIP to be processed correctly. Then I'm going to save this radiometric. This process will change the DNs or digital numbers of the image into the radians or radiation. Radiometric 2021 multispectral. We can wait for few seconds. This process will be completed. So now it's finished. And this is the image of our study area. So we have some classes here, for example, bare soil and agricultural lands, vegetation cover area, and here is river and trail for classes here. So after this, I'm going to apply uh, atmospheric correction. I'm going to use quark atmospheric correction, for example, this file, and OK. And here I'm going to select the Lancet. OK. Now it's corrected atmospherically. Let's check the values of the data here. Now you see the minimum value is 0 and the maximum is up to 6,000. So I'm going to change all the values into the, I'm going to rescale this image and change all the values between 0 and 1. So for this case, I use the bond math here. And I'm going to type here float B1 less than or equal to 0 must be considered as 0 less B1 greater or equal to 6,000 must be considered as 1 less B1 greater than 0 and B1 less than 6,000 must be divided by the value of retrieving this range. So like this. Load B1 divided by 6,000. And add this to the list. Let me check out. I think I left a parenthesis here. Okay, now it's okay. Okay. Now from here, I'm going to select all the bonds of the quark atmospheric correction image and specify a destination. Example, multi spectral rescaled. Okay. Now we have this image rescaled here. And whenever we change the statistics, the values must be between the 0 and 1. And you see the maximum value is 1 and the lowest value is 0 also. So by this, after rescaling your image, you can apply it would be a little bit better and you will experience better ways to apply spectral indices, and you get a better result. Uh, if you want to apply a spectral index or any other calculation, just it would be like this. For example, I'm going to calculate the NDVI, and as you know, NDVI is calculated between the rash bounds of, for example, we use B5 and B4, or inline set of 8, or NIR and rate bound. And the formula is like this. For example, NIR minus by R and divided by NIR plus R. So you can apply this very easily here. For example, float, you can open two parentheses, and now B5 minus B4, or you can type down B1, B2, and also these bounds will be specified later, and divided by B5 plus B4. And from here, when you click OK, bond 4 is our rate bond, this one. And bond 5 is our NIR bond, or near infrared. Then you can specify your destination and click OK. So now the value of this index must be in the interval of the -1 and +1. Otherwise, you must uh, reevaluate your calculation or your process. So whenever you change or you create your image, and you can apply a threshold here, threshold ROI. For example, I'm going to set that more than 0.3 is vegetation covered area, mostly, or 0.225. Okay, now the ROI is created here. I'm going to load this threshold NDVI on the NDVI image. Now you can see all the vegetation covered area in this image. So now we know that our vegetation covered area is at the interval of higher than 2.5. In that time, you can use the decision tree to separate your vegetation covered area as a separate class, or you can define this. For example, this is vegetation class. And here, I'm going to say B1 equal or greater than to 0.2 5. And okay, from here I'm going to define my bond. Okay, now when I click here, you can see the values here, or the formula here, or the logic here. And rather than this class can be classified into the class 0. So from option here, you can execute your decision tree by saving DC and DVI. I don't want to save this, and I close all these files. So now go through the saved file, and here we have DC and DVI. And when I click here, change color table, or create a color slice, and I change the colors. I set a green color for this and a yellow color for the next class. So now, okay. Now here we have two classes. By this way, you can separate the classes of your image, even this water, it can be it's water, it can be urban area or built-up areas, and it can be agricultural lands. You can specify your classes, any type of classes. But here we have some built-in indices, its value. For example, let me search here, spectral indices. When I click here, and when you introduce your file to this, then you will get a list of the indices here. Approximately 36 index according to our uh, introduced data to the tool is available here. For example, normalized board rash. You can use this for the locations that have got fire, and after that you can access the bushfires area and multiple type of vegetation covered area and built up areas in any of these. So for this case, we have various type of vegetation index here and optimize soil adjusted vegetation index. For example, I'm going to apply for this product, and you can see a feasible result here. For example, let's compare this two. When we calculated a simple NDVI, and part of these areas were consist of our vegetation covered area. But when we applied this soil adjusted vegetation covered area or vegetation index, now our vegetation covered area has quite the location that's covered by the location. Now it has a feasible result. So if I apply color slice to this area, now you see the yellow and red locations are the location of the vegetation cover. Now you can see the river well, If we see the next image, so it's some soils in some other parts of this study area is part of our vegetation coverage area here. So you can use any of these, but I'm going to use the board rush index in this tutorial. Because of this, uh, I need the perfect data or the data of the same area that I've got a fire in the earlier days. So let me check my download. Here I have a Lancet image from the Turkey that was struggling the let me create a new folder here that was struggling the fire into the forest a few days ago. Now we're going to check out the burned area.